Okay, some people had some questions about this truss problem. We have kind of a bracket on the side of a wall here, and you can't assume this is 90-degree right triangle. We're going to have two pin supports on the wall. So we're going to have a force there and a force there and a force there and a force there that we need to figure out what they are. So the first thing we want to do is ups equal downs and lefts equal rights and torques. So the best thing probably to do is figure out the torques right away. And we're going to use point E as our reference point so that we don't have to worry about either of the two forces that are working on point E. So if I go over to here and then times this force, that's 2 times 3, and that would be a clockwise torque. So clockwise, you have 2 times 3, that'd be 6. And then you'd also go all the way over at 6 times 1.5, that is 9, for a total of 15 clockwise torque. What other torque do we have on here? Well, we have this distance up here times that force right there. Okay, and therefore we would actually know that this force here is going outwards, because that's the only way that's going to make a counterclockwise torque to balance it. You might think, well, what about this one up here at the top? That's not providing any torque. It's actually working, if I draw it all the way down, it's working on this point down here. So that's not providing any torque. So this one here going out, this has to be going to the left, would be providing the torque. So that force times how far is it from E up to A? Well, we have a right triangle here, and we have a 30-degree angle. And so this opposite side over this adjacent side should give it to me. So that'd be tangent of 30 equals x, the opposite side. This will be x over here, over 6. So x is going to equal 6 times the tangent of 30. So when I do that on my calculator, I get x, this side over here, of being 3.46 meters. So the people I was helping with, that was where it went wrong, I believe. That should have been 3.46 over there. And so so the force times 3.46 should equal 15. So 15 divided by 3.46 gives me a force up here of 4.3. Okay, now that's balancing all the torques around this point. That helped us figure some things out. So then now what do we know? Well, we know lefts have to equal rights. We only have one going to the left, so that means this one here is going to the right, and that is 4.3. 4.3. Okay, so we still have this one up here and this one down here. We had to figure out if those are ups or downs or whatever they are. Okay, but we can work on that a little bit later. Let's go ahead and try to start figuring out some of the members on the internal member tension and compression forces in all these other members. All right, so let's go down here to the bottom here in part C. What do I know here? I know that I have a 1.5 coming down, which means I need something going up to balance it. So the only way I can get an up force is to know what this thing here is doing. This thing is either a right and down, or it's an up and left. This thing would have to be an up and a left. That's what it would have to be. And we know that this up right here is 1.5. Okay? So if that's 30, this is 60 degrees. And I can figure out this side over here, this x force right here, by taking tangent of 60. Tangent of 60 would equal x, opposite, over the adjacent 1.5. So I'm going to take tangent of 60 times 1.5, and for this x right here, I get a 2.6. So I can figure out the internal force in BC now by doing Pythagorean's theorem there. 2.6 squared plus 1.5 squared, square root that gives me something really close to 3. Okay, and we know that this force is going up and to the left, which means it's going this way. Okay, that's how we resolve that into those two forces. And that is a tension So this is going to be a plus 3 right here. So maybe I should change the color there. This one here is a plus 3. Should be the answer to BC. Okay. So remember, once you have one of these in here, you can come up here and you can draw it down this way too. Both ends of that thing. This is a plus 3 right there. Okay, now a lot of things are going to fall into place now. If we know down here that we have around this point again, we had something going to the left of 2.6. That means this thing had to be going to the right of 2.6. And if I know that, then I know that it's going to go this way also. And then I have another answer. This is a compression. They're going into the points. So this is going to be a negative 2.6. A negative 2.6. Now that actually still helps us out some more. Around point D is pretty easy. Either are going up and down or left and right. So if I have a negative 2.6 coming in here, that means I have to have one coming in this way, which means this is going out that way. And if I have this one coming down at 2, that means this one's going up at 2, which means right here this is coming down at 2. And so I just got a whole bunch more answers. So this right here, BD, is a tension. It's pulling the joints out. So this would be a plus 2 for that member. This one over here, ED, is going into the joint. So it's also a compression, and this would be a negative 2.6 as well. So we got a lot of answers all figured out there. Okay. Now we need to figure out AB, and we have to figure out BE also. All right, so what do we got? Okay, so up here, so we have a force going here. We don't know if that's up or down. We have something in AB. So this we know has to be going over this way, and we know that has to be a 4.3. Therefore, we know this has to be going down, which means this thing is going to go this way, which means it's going to be a tension. And we can figure out what that is by taking 4. Well, I guess we still don't know what. So this, we know that this here now is going up then. We know that that's going up. Okay? All right. Let's see. What do we also know here? We know that this angle up here is 60 degrees. So this angle in here is 30 degrees. And then we could take the tangent of 30 would equal this force. We'll call it y. Tangent of 30 would be y over 4.3. And if we figure out what y, then it would be 2.5. We can now do Pythagorean's theorem with both of these and get this one here in the middle. And this one here in the middle would be a plus 5 because it's going to be a tension. It's going to be a tension in there. Okay, I'm going fast because my iPad's about ready to die. Now this was up at 4.3. Okay, so now we can figure out what this one is down here because we have ups and downs. Let's look at this there. We have an up of 4.3. We have a down right here of 2. We have another down here of 1.5. Okay, that gives us a total of 3.5 and a 4.3 up, which means, whoops, sorry, I messed that up. Yeah, this 4.3 is right there. Oh, I'm very sorry about that. Yeah, we figured out this right here was 2.5, so this up here was 2.5. Okay, so that up is 2.5. Okay, sorry about that. So I have a 2.5 up and I have a 3.5 down, which means I still need a 1 up. So right here I know that this is actually 1 Newton up. 1 Newton up. I got that one figured out. Okay? All right, so what does that mean? So that means here I have 4.3 going in. I have 1 going up. I have a 2.6 coming in. So what does this have to be? This has to be an over and a down. And I know that this over has to be, so I have 4.3 going to the right. I have 2.6 going to the left. How much more do I need going to the left? I need like 1.73. 1.73 plus 2.6 gives me the 4.3. That's how I know how much is going over. What is this one coming down? Well, it has to be equal to this. So it has to be 1 going down. I can use these two to do Pythagorean's theorem. I'm going to get forces that are going like this. They're going to be compressions. And if I do Pythagorean's theorem, I can solve this to be a negative 2. A negative 2 with Pythagorean's theorem. And I have them all figured out. I did that super fast. I tried to do it really fast, but you can pause it and go back and see exactly what I did. Sorry about the part up here. That I kind of got that mixed up. That was a 2.5. So hopefully you can go back and see why that was.